Bonjour, je m'appelle Ole. Je cherche mon chat. I'm sorry that's all I remember from 2 years of French in school, and I don't know why it's so random. Okay, but today you're here because you want to learn about Elixir. I think that's pretty cool. If these slides up here, even though they're like super big, don't work for you, you can go to bit.ly/takeoff-elixir and you can get the same set of slides on your local device if this may help you to consume this talk. This is where I live, right in the very, very, very north, right there in a town called Hamburg. That's in the very north of Germany. Even though it's the second biggest town in Germany, no one really loves it because it's not super fancy. But I enjoy living there. A very long time ago, at this exact place, I was here already, and this is how I looked back then. Very young, very foolish. But okay, that's enough about me. So the title of the talk is about your Elixir fancy pens. So we obviously need to talk about pens, right? And if a dog would wear pens, would it wear like this or that? What do you think? Okay, I know that's a tough one, but we can have more of these really complex decisions to take. What about a T-Rex? So I totally have my opinion on this settled. And in the title, there was not only fancy pens, but also Elixir. So let's talk about Elixir. And I like to start off with the question, why do you want to learn Elixir? Well, this is a single track conference, so probably your answer might be, I have no choice. That's fair. I hope I can still get you excited. One of the reasons is a blog post that came out almost 2 years ago, where the Elixir or Phoenix team proved that the Phoenix framework, which is Elixir's web framework, can handle 2 million concurrent WebSockets connections while maintaining a 1-second broadcast. And the reason they hit this 2 million socket limit was not because it was a performance limit, but because of how they configured their servers, because they thought they will never ever hit this limit. So it could have even been more. So if you're planning to write a real-time application where you need to broadcast messages, like every modern mobile app, Elixir is definitely worth a look. And when you're maintaining a big tech stack, you have a lot of requirements, right? You have an HTTP server, you want to have request processing, you have long-running requests, server-wide state, all of this good stuff. And in a classical Rails background, which is my background, you will need a whole lot of different tools for all of that, right? So your HTTP server would be something like Nginx, then you have Ruby on Rails, you might have Go, Redis, all of this. I'm pretty sure you're familiar with that. And in Elixir, this would look like this. So your HTTP server would be in Elixir, request processing is Elixir. So everything it's a one-stop shop basically, right? So you can have all of this functionality without talking to the ops people. I mean, we're honest here. All of this having a one single solution is because you don't need to go to the server and install weird like Fedora packages. This is at least how it was for me. So there's also performance, right? This is a classical Rails Hello World app, and this was on my machine, right? So whenever we talk about performance and performance comparisons, keep in mind that you shouldn't trust like anyone upstage, like no one, right? But still, I wanted to show off like what I had on my machine, so I want to share this experience a bit. And when I wrote the same Hello World thing in Phoenix, I was able to cut it off to 22 milliseconds, up from 600. And even though this might not be like super realistically because no one writes Hello World apps, I think the order of magnitude in difference here already shows that Phoenix is a great framework that's worth investigating also for performance reasons. So it's about scalability in Elixir, right? And resilience. So resilience is the power to adapt from a crash, or the power or ability to return in original form position after being bent, compressed, or stretched. So when in tech, usually it's you're featured in TV, and then the whole French nation runs to your app, and you have one little server in one-on-one, and they just can't handle it. So how would your app react to that? My usual Rails app would just like keep laying down there, being crashed and sad, and that makes the user sad, and this makes my boss sad, and this makes me sad. So everyone is sad, right? Just because the app wasn't able to recover. And Elixir is pretty great because from almost every state, it can recover back into ready state without human interaction. And again, as for all tools, the tool is only as good as its operator, right? You can misconfigure your Elixir stack AF, and you wouldn't get any of this. And when I learn about a new language, and I'm attending a conference like you do, and there's someone on stage telling me about this new language and why you should use that, I always miss one point. And this is, I like to know, when should I not use it, right? If 10 people at a big tech conference have the one perfect language, there must be a flaw in there, right? There can't be 10 perfect, there can't be 10 one solutions for a single problem. So as we all know, because we work in this field for a long time, there is an area in where a language can really shine, and also there's an area where a language is not the best fit. And when you want to learn about Elixir, I want to tell you when you should not use it. And one is definitely raw computing. So if you need raw computing power, like raw number crunching, you shouldn't use Elixir. There are better languages for that. Elixir is fast, and also you can use it for that, but you won't get as good as results as you would get from using Go, for example, or Rust. And when we talk about how Elixir uses system resources later, you will see why this is. And another reason when you should really never ever use Elixir or Erlang is when you want to use any system libraries on your system. Because Elixir, in order to give you all the guarantees about scalability, and especially resilience, the whole Elixir and Erlang stack needs to have some guarantees from its underlying libraries. And all the stuff that's implemented in all Erlang and Elixir have these promises and have this contracts. But as soon as you start implementing any weird C libraries that like someone wrote and published on SourceForge, Elixir can't give you the guarantees, obviously, right? So when the system library crashes, your Elixir stack would also crash. So while you can technically have Elixir talk to system bindings, it's not a good road to go down. Let's take a look at more pants things here. I think that's pretty easy, right? It's obviously the left one. That's my favorite, though. I think that's also pretty clear. It's the right. I mean, no doubt. Cool. You're here to learn Elixir, and I talked a lot about Elixir, but here's the sad news. When you want to learn about Elixir, I need to talk about Erlang. And you'll be like, shit, this is not what I signed up for. Like, I know. But trust me, Erlang isn't as bad as it looks. I know it looks really bad, but it's not as bad. And I think when you learn a new language, it has two sides of it. The one is the syntax, right? You look at this and you understand the commands that you're giving. And the second is the ideas, the concepts. And in Ruby, it's like the idea of how to write Ruby and the ideal code of write Ruby or Elixir. And when you don't know any of the concepts or the syntax, then you look at a language and you have no clue. This is what happened to me when I looked at Erlang for the very first time. There was the syntax. I mean, it's really horrible. And then also the ideas that are in the language. I was looking at it, and after an hour, I just like crashed and I gave up. So 2 years later, I learned Elixir, and because Elixir looks like Ruby, I was able to grasp the syntax right away, and then I could learn the concepts. And when I knew about the concepts, then again, looking at Erlang, and I only had to learn the syntax, which is still awful, but I can learn. I'm now able to read Erlang, at least, which like I think is an achievement. So when you talk about Erlang and Elixir, you might wonder how they relate. This is the common denominator. So there's the Beam VM, the Beam virtual machine, which is kind of comparable to the Java virtual machine. So Elixir runs on top of the Beam VM as also the Erlang machine does. So everything, that's basically what they share, right? And the Beam VM gives an abstraction to the operating system. So Elixir and Erlang share the same virtual machine, and the virtual machine then has all the integrations to the operating system. This is how they relate. If I would have to draw this So this is the conceptual idea. Like the technological implementation is a bit different. We would need like 4 more squares, and it would really confuse everyone. So I think from a concept, this is okay to get. When you look at how it's compiled, Elixir is compiled down to like an intermediary Erlang step before it's compiled down to a binary beam VM executable. But this is really nitty-gritties, and conceptually, this is how it works. So I assume, because it's an introductory level talk to Elixir, you have never seen Elixir, and that's totally fine. So let's take a look at the basic syntax here. In order to look at this, we start our interactive shell, IEX. We boot it up, and we can do very simple things like 1 + 2, 3, and obviously 0.1, 0.2 gives you that because floats. And this is not an issue of Elixir or Erlang, right? You have this in almost every language. Just try it in your favorite language. You can have variable assignments. So thing would be maple. You have string interpolation. So you can have like sing syrup is maple syrup. So let's clear this thing and take a look at data structures. So we have a tuple, which consists here of an atom, a string, and a number. We have lists, which is a, I think, well-known data structure. And then you can also combine this where you would get a list of tuples, which in Elixir is called a keyword list. And you see that the syntax here changes a bit because it is just a different way of writing it, right? So, whoopsie. So when you look here, you have a list, and the first element is a tuple, the second element is a tuple, and the first element in the tuple must be an atom, and then the next one could be any term, any value, and it would give you, it's like a map, but it's not a map because you have maps. And the only difference is that in a map, a key is unique, while in a keyword list, a key can occur multiple times. Okay, let's switch back and look on how modules and function works. First of all, it's important to note that code is organized in modules, and every module has a function. So it's a functional language, right? There's no objects, there are no instances. All of this does not exist. We have functions and data. This is it. And you have implicit returns, like in Ruby. The last statement that was executed will be returned. There's also this thing called the pipe operator. Who of you have heard about the pipe operator? Cool, that's like half the audience, great. So for the other one, this is the pipe operator. Great. Keep going. No, so what can it do, right? You all know this code, right? You could fetch something out of something, assign it to a variable x. Then you would pass this down to the function transform, get another intermediary variable, and then you pass that down to save, and you would get the final result. So you have two intermediary variables here. And from the outside, you don't need that, right? It's just it's just too much. You don't need that. And you can say, well, you could write it in a different way. So you could write it that way. And while this is totally true, I think it's pretty hard to read, right? As humans, we tend to start on the left and then read to the right. This is not how this works. You would start in the middle, and then you have to deconstruct how all of this works and what gets passed into what. So while this technically works, it's not really readable. I wouldn't this consider good code. So here's how the pipe operator can help you with that. So whatever is on the left-hand side of the pipe operator, so whatever the return of the left-hand side of the pipe is, will be the first argument to the function on the right-hand side of the pipe. Does that make any sense? Yeah? Cool. Cool. So how can we rewrite the function I just showed you to use the pipe operator? Well, you would fetch the ID, pass this down to transform, pass it down to save, and because we use explicit returns, you wouldn't even need like the last result variable. So this is code you see quite often in Elixir, and you can even use this just for like scalar values, so you can pipe any scalar value into a function. Because remember, whatever's on the left-hand side of the pipe will be the first argument on the right-hand side. You can also do this with multiple arity functions. Imagine transform would also need like an attributes something list, and then you would do it the way you would use to do functions. So you do like bracket open, and then you just give it the second argument, because the first one is always implicit through the pipe. When I talk about Elixir, we also need to talk about types. And when we talk about types in Elixir, we need to talk about types. Because it's not really a strongly typed language. However, though, we still get all the benefits that a statically typed language can give us. Let's take a look at this module here. We just call it pancakes because I love pancakes. And we can define a struct. A struct is a data structure that is named after the module it lives in, and it has a set of attributes. So our pancake can be done, which is a Boolean value. We have a function that is cook. It gets passed in the pancake. And then, because we're cooking the pancake, we just set it to done, because we're cooking the pancake. And here, type specs come into play. When you take a look at the struct, we can define a type called t, which itself is a map. So we have a custom type here. And t is kind of a, this is the way how you do this in Elixir. It's standard how you call structs that belong to a module. And we can also add a type spec to the cook function, and we say the cook function get passed in a pancake and also returns a pancake. Well, this is kind of, I don't know, this wouldn't excite me, right? When you look at this, like, oh, okay. What's really cool though is, first, when you have when you have type specs and they're not required, so you can totally live without them, and they're wrong, the compiler will give you a warning, right? It won't fail because so it trusts you to do the right thing. I think that's not a good idea, but however, it trusts you to do the right thing, and it will give you a warning when your type specs are not matching. And you have an extra tool called Dialyzer, which is a mixture of discrepancy analyzer, which analyzes your type specs and see if all of this makes sense what you wrote. Right? If I pass the return of pancake cook into something that doesn't expect a pancake type, the dialyzer would like bail out. And this can be combined with pattern matching. And this is really the coolest thing I think we have in Elixir. So I wanted to show you a bit of code. We start the interactive shell again, and we do x equals 1. What do you think? It get 1. So x has the value of 1. Now, let's do this. What about 1 equals x? Think about your favorite language, the language you use every day. What would you get? In Elixir, this is 1. And here's things start to get a little bit weird, right? When I first showed you the basic syntax, I said this is an assignment. And this can't be an assignment because you can't assign 1 to any value, right? This is weird. But what do you think happens if we do 2 equals x? In Elixir, this will give you a match error. So here we have the first hint that whatever we do with the equals here is not an assignment, it's called a pattern match. So whenever you see an equal sign in Elixir, it's not an assignment, it's a pattern match. And when the variable on the left-hand side, like in the first line, is unbound in the current scope, so there is no value bound to the variable, it will bind the variable to the result of the pattern match. So you can do this pattern matches also on more complex data structures. So we can, for example, match on a tuple. So the match result would be hello world 42, and as A was unbound, it would have the value of Adam, hello. B would have been bound to world, and C to 42. Here's an example again. If it wouldn't match, like a tuple is a fixed size list, fixed size length list, and if the length doesn't match, it gives you a match error because this is not matching here. And this is something you see in Elixir quite a lot, but oversimplified, because writing something like this, like plain in the code, doesn't make a lot of sense. But when you think about the right part here not being the direct value, but rather a function call that would return it, I think it starts to make a lot of sense, because you can check whether your function returned a good value, so it was successful in doing what it was supposed to do, with returning a tuple where the first value is okay, and then the actual return, or with the tuple, the first value is error, and then an error message, for example. This is a pattern you see quite a lot in Erlang and Elixir, because exceptions are not really used to guide code flow, and it's done with pattern matching. Oh, this also gives a match. So let's go back to our pancakes example, and I think this is where it really gets interesting here. So let's take a look at our cook function again. We pass in a pancake here, And we can also pattern match on function headers. So we can say that whatever we pass in there must match this expression. So we say it's a struct, it's a pancake struct that we pass in here. So if we pass anything in there that is not a pancake struct, it would give us a match error again, because there is no definition of the function cook that would match. And we can even go deeper into the data structures with saying that if we have the function cook that takes a pancake where the done attribute is false, we would just update the map, and every struct is a map internally. We would just update the map to set done to true, because it doesn't make any sense, obviously, to cook a pancake that's already made, right? But what happens if because I don't want to check the state of the pancake outside, so I still want to be able to pass in a pancake, even though it's done or not, to cook and still receive it. And I think this is one of the coolest things you can do in Elixir and Erlang. You can define, so you have function overloading, so you can overriding. So you can have the same function multiple times, and then have the compiler checking which function headers matches your current data, and then get that one executed. So if we pass a pancake that is not ready made, we would update it to done true. And if it's anything else, this is kind of the catch-all over there, then it would just return the pancake, because we know the first thing didn't match, so it's probably ready. So now let's take a look at how scalability works. And the secret formula of scalability in Elixir is really message passing plus scheduling plus immutability equals speed. So let's take a look at message passing first, right? So Elixir has an actor model, so we can pass around messages from processes into the process inbox. Let's start IEX again and see a little example here. So first thing we do is we assign the process ID of the current process into the variable cook. Then we'd spawn a new process that would send a message to the PID. The value of the message we are sending is that pancake, right? And when we hit enter now, this message was already sent. So the spawn process is already done. And the IEX process, so the shell process now, is waiting for the next thing to do. So where's the message? So the message is waiting in the process's inbox for the process, so our current process, to receive it from the inbox and process it. So here we just do receive and then inspect whatever we get. And we obviously got the pancake. So what's cool about this is that the receiver can decide when to pick the next message. It does not block the sender. The sender is always on block, and you can always send messages. And it's up to the receiver to decide when to process it. So you can also do, again, pattern matching here. So when we get past the pancake, it's dinner time, and when we get anything else, we want to inspect it first. So receive also does pattern matching. And you see pattern matching in Erlang and Elixir all over the place, because it's so cool. Let's take a look at this same process and what we just did. So we have the cooker process, and we have the cook process. And the cooker process has its inbox here. At the moment, there's no message in the inbox. And then the cook sends a message to the cooker, and the cooker can now decide when to pick it up. And while the cooker is doing its thing, the cook can also do its thing and send another message to the cooker, and then it would be again up to the cooker to decide when to pick it up. This way, you can have almost infinite scalability, because when you talk about processes in Erlang Elixir, it's not an OS process, it's an Elixir process. And Elixir processes are super lightweight and easy to spawn and kill. So it's not a big problem it doesn't give you a speed or performance impediment when you spawn processes. So every Elixir app you see out there that has a lot of traffic on it, it has up to 1,000, 2,000, even 10,000 processes running, and this is not a problem. This is okay, because the language is designed that way. Also, it has immutability. And if we take a look at what happened here, I said we are updating the map. Well, when every data structure we create is immutable, we are not updating the map. This is basically syntactical sugar of creating a new map with all the values from the left-hand side of the pipe and updating only the values and the attributes that are on the right-hand side of the pipe. So we are creating a new map. And whatever has a reference or whatever has a value of the left-hand side of the map, we are creating a new one. So we never change, right? Data in Elixir and Erlang doesn't change. So let's try to grasp this a little bit better and how it works internally. So let's say we have variable p and bind it to grain, and then we have px, which is bound to milk. So in our imaginary variable lookup table, p would be grain and then px would be milk. But what you have seen already is that you can do this. So I can again put something to p. So I can rebind p. And this is something that's not possible in Erlang. So in Erlang, every variable can only be bound once, and once it's bound, you get a match error if you try this again. Elixir does a little trick here, and this is basically what I try to explain here. Is when we do this, we get a new variable, we get a new entry, so we create again new data, and then we just move this it's not a pointer. So we move this variable name over, right? So the other one still exists, and whatever had a reference to this old data structure, can access it. I hope this makes any sense. So the old one still exists, and the new one is just rebound. So it's a rebinding of variables. You can never change the data of a process that it has already get passed in. This is just not possible. And now let's dig really deep into how the scheduling works. And I think this is pretty cool. And I think that's pretty interesting. And this is also what I promised right at the beginning, why Elixir is not for hardcore number crashing. So let's take a look at the Beam VM, more specifically the Beam scheduler. And for the sake of simplicity, let's call it a scheduler. A scheduler is the part of the CPU or the virtual machine that assigns CPU time to tasks at hand, right? So you have a set of tasks that you need to accomplish, like here 1 + 1, and a more complex task, like getting an absolute number of something, and you have a given set of CPU time. In this example, it's fairly easy how you would distribute it, right? You would just assign the CPU time needed to the tasks you have, then the task would be done, and the CPU would go idle again. Well, here's bad news. Reality strikes in. But this is not how it looks like, because usually you have way more processes at hand than, especially in a server landscape, than you have CPU time available. So here's my question to you. If you would be the scheduler, how would you assign the CPU time at hand? Let's take a look at how Elixir does that. So Elixir would go ahead and distribute the CPU time available evenly. So every process gets the same CPU time, reduce the workload to do, and then in the next cycle, give the same CPU time out. This makes the system predictable. And this is really what Erlang and Elixir is about. It gives you predictable systems. So even under load, all processes get slow equally. So this makes the system, again, predictable. So you won't see, for example, if you have a Go or Rails app, that the 90th percentile get worse and worse and worse, while most people still get their requests served in a fairly quick manner. Because what most schedulers do is they would just assign all CPU time available to the most recent task. That would mean that the first task would be processed pretty quick, and also quicker than we would have it in this model. But also the task on the right-hand side, more on the right-hand side of this thing, would be idle more. And when we talk about browser and server stuff, they would probably time out because no one takes care of their stuff. So even though it sounds weird, when in Elixir everything gets slow equally, it's a good thing because it keeps your app predictable and also the behavior of your app predictable. And there's also more to this. For example, Elixir. So this obviously a very oversimplified model, right? There's way more to writing a scheduler and doing the logic of a scheduler. And in Elixir, what I like about this, how it does that, is that processes that generate a lot of messages get less CPU time assigned. So when you generate a lot of work, the scheduler gives you less time to generate work. So that it tries to calm down the system. There are also supervisors. That's part of OTP. I can't cover this in this talk. It's basically a process that supervises other processes. And this is why Elixir is so resilient, because the supervisor is really simple. And when you have really simple processes, they're less likely to die. I mean, that's something you experience in everyday programming, right? And when it's easier and less likely to die, it can supervise other processes that do complex work better. And when these complex processes die or crash, the supervisor can just restart them again and link them up and set them up again to do great work. right? You may have lost work in the middle of the crash, but you can boot up again, and there's no need for an outside like operator or something to do something. Again, OTP, it's the open telecommunication platform. It's written by Ericsson in Sweden. It has everything you need to write distributed applications, like gen servers. And I hate the name gen servers because it translates to generic servers, and this meant like nothing when I was learning all of that. And it's basically a process that keeps looping and listen for messages. That's basically the idea of a gen server. Again, it has supervisors. Supervisors can have supervision trees. There's also Phoenix, which is the web framework. So there are a lot of stuff that I haven't covered. There's Mix, which is like Elixir's build tool. There's Distillery for compilation. All of this is like, we can't cover this here. And if you want to learn more about this, I can really encourage you to take a look at the online docs. When you walk out here, I want you to feel like an expert Elixir programmer. And if you're really interested in language, you know what happened in the last releases, right? So you know now that Elixir 1.5 got its own code formatter. You know that Elixir 1.6 gave you dynamic supervisors. And that 0.7, which is not released yet, will probably give you property-based testing, which is pretty cool. Also, and this was what like hooked me into the language, this is the Getting Started guide, and it covers everything from variable assignment and basic data structures up to OTP and gen servers. And when you're at the last two steps of OTP and gen servers, you're about to implement your own TCP-based in-memory data store in an actual language tutorial. I think that's pretty cool, and this shows how easy it is to write these network applications in Elixir. My name is Ole Michaelis. If you want to keep in touch with me, Ole Michaelis on Twitter and GitHub. That's my blog where I don't blog, so it's a website, I think. I work for a company called DNSimple. We do domain management automation, so you can buy and host domains with us. We automate everything. We have an API-first approach. And I brought a lot of stickers. So just if you want any of the stickers, just come and find me. We even have Elixir stickers. I think they're pretty cool too. So yeah, just come and find me. That's all I got. Thank you very much. And it was right on time.
We might have time for one question.
Hi.
Hi.
What do you use Elixir for exactly?
What's that?
For what do you use Elixir exactly?
So at DNSimple, you mean?
Or for example, in your life?
So what I did in Elixir, this was kind of a learning project. I wrote an HTTP2 server. That's what one does. And this is what Elixir is really great in. So it shines when you write any server applications. This is nothing that I put to production ever. So just a learning, a fun project. At DNSimple, we do a lot of Elixir. A lot is maybe an overstatement. We have 3 projects in Elixir. And the biggest of it is not live yet. So there are 2 really small apps that just do little like connection stuff, so it talks to 2 APIs. And the big component we're doing is probably something I can't like elaborate a lot on camera, but we are adding new functionality to the DNSimple app where we are not a reseller of domains anymore, but we start selling our own domains, so we are acting as a registrar, and this is what we are doing. That's a really complex app.
Do you have any public repository where we can look at?
Yeah, so we have one public repository that's the Elixir client. So the DNSimple API has like 6 clients that we ship it with. So there's Ruby, PHP, Java, Net and stuff. And there's also an Elixir client that we wrote. So if you want to examine any Elixir, that's probably a good way to go. Also the Phoenix app is probably pretty cool to check out. And also if you want to see a Elixir app, like a complete app, there's Hex. Hex is the package manager. And that's also written in open source. So there you can see a Elixir app that's written by the Elixir maintainers. I think that's pretty valuable to check out.
Okay, thank you.
You're welcome.
Thank you, Ole.
Yeah. If you have more questions, I'll be around today and tomorrow.